All right, so let's go ahead and start up a template, Python with Turtle. This is day 8. This is real. I'm just really keeping a count on this semester. At least I'm not counting down or something. I'm counting up. So it's not like I'm showing you, like, oh man, let's get out of here. No. I'm excited. So once you go ahead and open up Python or a REPL with Turtle, you'll have some template code in here, and we'll kind of understand what all of these things do, and we'll just kind of do some more mathematical drawing. But if you just run it, we can see right here that this is a graphics library that is built into Python. You just have to import it, and it's called Turtle. So to just go ahead and start with a clean slate, let's go ahead and just delete all of this right here. And I think it's always good just to start from scratch. All right, let's go ahead and turn off these keybinds. Okay, so like I said, it is a module. Remember, modules need to be imported, so we're just going to import Turtle. And what we're going to do is we're going to create a turtle. This is so much easier. It's not like you have to put them in a tank or anything. You just are going to say, let's call our turtle Bob, because to me, Bob is a nice turtle name. And the way we're going to create a turtle is we're going to use the lowercase turtle. So what this is going to do is go into the Python module and find a class named turtle. So we have created our turtle named Bob. And again, to see that he is a turtle, let's go ahead and just print Bob. And if we run this, you can see over here on the right, we see main.turtle object. So of course, to actually do something with Bob, what we're going to need to do is, this is the graphics program, and we'll get into some more of these later in the semester, namely tkinter and Pygame. But in the Turtle module, there is a method, which again is just a function in there called main loop. So whenever you're drawing, basically it is just going to constantly be doing a big loop, like it's a while true loop, and it just keeps running. So a lot of kind of that logic is abstracted away with this right here. So we're going to need to run that. And what we're going to do now is make Bob go forward. So bob.forward is a method that will make Bob go forward. And let's make him go forward 100 pixels. So if we run that, we can now see this arrow over here go from the center 100 pixels to the right. By the way, by default, this is your standard Cartesian plane, so he starts at 0, 0. So 0, 0 is right there in the middle. To me, like, if it's a turtle, if the module is called turtle, that needs to be a turtle, not an arrow, right? So what we could do at the beginning is I'm going to go ahead and change the shape of Bob by using a method called shape. So it's going to be on our, it's going to be attached to Bob specifically. And we're going to go ahead and put in an argument turtle. And make sure the argument here is a string. And now if we run this, we can see Bob is officially a turtle. So that's, to me, that's a little bit better. So, and you remember, as you get used to modules, one thing that I always recommend you do is actually go to the documentation for the module. I was checking before. I actually think REPL is using a Python 2 version of Turtle, but again, I think a lot of it stayed the same, so I'd have to do a little bit more looking to it. It's been around since Python 2.5, even though we're using Python 3.8 and 3.10 is the current version. But whenever you get a start a new module, I always recommend go to the documentation, just kind of look what's there. Like, look at what we can do with this. And by the way, I saw a post a while back on Reddit, and someone was playing with the turtle module, and this is what they got the turtle module to do. So this right here, they wrote a program that randomly generates a picture using the turtle module. So some people have spent a lot of time with this, and just like, we're going to just be drawing little shapes. But this is some of the things that you can do with this module. It's pretty impressive. You can change its color. You can go ahead and move it to different locations. We are not going to be able to do this by the end of the day, but if you ever want to play with it more, it certainly is something fun to play around with. So whenever you are introduced to a new module, I'd really encourage you to go to the documentation and just kind of look through it. There's some, especially what I do is I will always kind of look at the methods. Again, methods are just functions that are attached to a certain class. So again, the class here is turtle and those methods. So you can see like we have a bunch of ways to move and draw. If the turtle is just not going fast enough, you can see there's a method called speed. There's certain things like color. And I think the one we just used was shape. So where was that? Right here. So appearance, shape. So you can go ahead and do that. And there's arrow, there's turtle, there's circle, there's square, there's triangle, there's classic. So that's the answer to your question, Andrea. To figure out what is available, you have to go ahead and use, look into the documentation. So as we introduce new types of modules, we'll talk about matplotlib later this semester, numpy, sympy, and a lot of other things. I think in the next project, which I'll demo at the end of the day, you're going to use the random module. So I always recommend go to the documentation, see what's there, play around with it a little bit. So you may even be like, oh, okay, maybe, by the way, how did I know that it was origin was at 0? Well, I was playing around with it a little bit before class, and I used this go to or set position method. So maybe you're like, okay, yeah, you can go 100 forward, but then I want you to go to, let's say minus 129. And then I run that and I see like, okay, it goes forward, but then it goes over there. So it went over to minus 100, up 29. So all that to say is whenever you're in something new, just play around, see what's there. You're going to learn a lot just by doing that. So, of course, our goal is to essentially draw some shapes. We're going to do a little bit of geometry in here. So let's say make Bob go forward 100, but then let's make Bob turn to the left 90 degrees. Then let's make Bob go forward another 100 pixels or 100 units. So you can see I did make a little bit of a mistake here, and that is because I was not spelling the word forward correctly. So let's try that again. So you can see right here, he does have to turn, but forward is going to go the direction that he is currently heading. So he is, of course, heading to your standard position 0 degrees, but we had him turn left 90 degrees. So maybe just as a little bit of an exercise, I have a couple exercises. That's how we're going to do the day. So exercise 1, let me give you about a minute. Modify the program to draw a square. Yeah.
Can we not open up extra files?
Not in the restriction that we have in the template where it's Python with turtle. Unfortunately, yeah, I was checking before. So you might just want to have like a notepad or something. And again, I post all of this code. So yeah, unfortunately, there is a restriction that we can't use separate files here.
How do you comment something out again?
To comment something out, you can go ahead and just highlight everything and hit Command /. So I'm going to give you a minute to draw a square. So the simplest approach to drawing a square is just to continue with this pattern. So turn left another 90 degrees. Bob should then go forward another 100 units. Then Bob would need to take another left and then go 90, so 90 degrees to the left. And then Bob is going to need to go forward 100 units. So if we go ahead and run this, my turtle does indeed make a square. So how many got approached at something similar like this? Good. And again, a lot of today is kind of a case study. If you look in the Think Python book, that's what we're kind of going through. We're going to go through the exercises in that book, and it's a case study on basically development. So if you notice right here, yeah, you see forward, left a lot, but it definitely does seem like there's some repetition in what we're writing. So instead of writing forward and left, what the better approach would be is to use some sort of construct to repeat. And we, of course, have the for loop. So for I in range of 4, what I'm going to go ahead and do is make Bob go forward 100 units, and then I'm going to have Bob turn left 90 degrees. So if I repeat this 4 times, it does indeed make the square. So this is much more readable. There's this idea of like, okay, he's just going forward, turning left. And again, remember that we technically don't even need to use I here. Like if you don't want to use that variable and just worry about it, you can just use an underscore. I'm going to typically just put I, but notice that none of my actual actions or logic relies on I. So again, just kind of letting it know there. So the next thing that you might be thinking of is like, okay, I wish that the code was a little bit more self-documenting. That is to say, I wish I could put comments, but you know what? This is something like, what if I want to go ahead and maybe draw a square here in the middle, but what if I want to go ahead and draw a square over here on the left? Maybe I'm trying to make a maze or something like that. So it would be nice to be able to repeat this. And of course, instead of just doing a for loop a bunch, let's go ahead and encapsulate this into a function. So what I'm going to go ahead and do is define a function. So def, I'm going to just call it square. And what I'm going to do is it's going to take a parameter. I'm going to just call it t for turtle. I have to say, okay, what turtle do I want it to go ahead and draw, or what turtle do I want to draw a square? Well, what I'll go ahead and do is then for I in range of 4, oops, what I'm going to do, not here is Bob, but the turtle that I pass in, t, that is the turtle that will go forward 100 and then left 90. So I'm going to delete, I guess I'll just comment this out up here just so you can kind of see how our progression is gone. But now we have a function called square that has a parameter of t, which is again a turtle. And for I in range of 4, it's going to go ahead and do this logic. And again, if I run this, it does nothing. It just stands there. It's like, turtle, make a square. Well, there's Bob, but remember, we need to actually go ahead and call this function. So I'm going to call the function square, passing in Bob. And again, it's not going to do anything, but when it gets to line 25, it's going to be like, okay, Bob will then be sent into this function, and basically wherever you see t would be replaced with Bob. So I run that, and I am having the hardest time spelling the word forward today. So there we go. You can see that the same action is occurring. So again, this maybe just here for a note, a little bit more of kind of the logic is we just introduced the idea of encapsulation. So encapsulate, if you think about to encapsulate something, you think of a capsule, you put something in a capsule. So what this is just simply we're wrapping a piece of code up in a function. So the good thing about this is a couple things. It attaches a name to code, which serves as a kind of documentation. So this is nice. So all of a sudden, like if you had no clue if you had never looked at a program before, but if you saw square, all of a sudden, the first time you read it, you're like, oh, this probably is the logic to draw a square. So it is self-documenting. So it also allows for easy code reuse. So like I said, if you had to draw squares in more locations, you could just move Bob to a different location and then call the square. Notice that this says nothing about where that Bob needs to start at the middle. It just, we could have done other stuff to move Bob to a different location. You'll see that question and exercise that'll be posted later this week. So there's a lot of ideas about encapsulation. If you ever find yourself copying and pasting, consider encapsulation. So I was working on the project for the next one in this course, which my goal is to have it posted by tonight. I'm going to demo it a little bit at the end of class, but I was just finishing it up in office hours here before class, so I'm going to get that out to you all tonight, tomorrow morning at the latest. So project 2 will be released here soon. It's going to be a fun one. I was having a lot of fun with it last night. But if you ever find yourself, especially as we get a lot more code, that you're copying and pasting, consider writing a function for that logic. It really makes the code readable. If you find a mistake in your logic, you don't have to find the 12 different places you reuse it. You just have to go ahead and just fix the function that you've encapsulated the logic into. So there's it's very good programming style, and we'll hopefully have some time to talk about styling a little bit at the end of this class. So that's exercise 1. Any questions so far? That introduces encapsulation. All right, so let's go ahead and look at the next exercise. So I'm going to give you a moment to read it, and then I'm going to give you maybe 2-3 minutes to try it. Then we'll of course go over it, and I'll kind of expound on it. But I think it's always a good idea, especially now that we have the basics, to try things just from direction. So exercise 2: add another parameter named length to the square function. Modify the body so the length of the sides is length, and then modify the function call to provide a second argument. Run the program and test it with a couple of different values just to see how it works. So what you want to go, this is known as the process of generalization. So we talked about encapsulation. What we're here is generalizing it. Let's go over the logic. So you'll find that pretty much any time you have something hard-coded in here as numbers is an opportunity for either generalization or definition of constants. So I've used, sometimes when you just have random numbers written in your code, these are sometimes referred to as magic numbers, because they're really not telling us what it is, why you have 4, why 100. So what we're going to go ahead and do is generalize this next. So just what is generalization? Adding a parameter to a function is called generalization. So I'm going to go ahead and instead of just taking a single parameter named t for the turtle, we'll go ahead and define another one, as the directions said, called length. And instead of 100, we're going to go ahead and replace that variable with the length. So of course, now we can go ahead and have Bob, and he needs we'll have it draw 3 squares. So Bob will draw a square of length 10. Bob will draw a square of length 100. And lastly, just to make sure our logic is making sense, let's have him do 1,000's maybe a little excessive. So let's do maybe like 329. Why not? And then if I run this, you can see he does a little square, a bigger square, and I did not spell Bob right. Sorry about that. Let's go ahead and spell it with a zero, O, not a zero. So you can see right here, we have generalized this function. Bob is gone. He'll be back in a sec. Don't worry. He's back. But you can see that's the idea of generalization. Does anyone have any questions on that? All right. By the way, let's say that if this is a let's say you have a really like a kind of a default number in mind. If you just do square Bob still and you don't put a second argument, it's gonna yell at you. It's gonna say, hey, square takes exactly 2 arguments, but 1 were given. If you want to have a default argument in, what you can do is just say it right here at the beginning. Set this to set this to 100 by default. No, let's do 90 just so it doesn't overlap with the other one. So if what this does is say, set it to 90, but if something else is passed in, it's going to overwrite that 90. So this is how you do a default argument. So you can see there's the first one it did was 90, the second one was 10, and then the third 100, then 329. So again, that is how you do a default argument. That's nice just because it kind of protects you from running into errors or something. And if you have kind of a certain case in mind as default, that's kind of nice to have. All right. So I'm going to go ahead and just delete these calls. We'll go ahead and leave that square there just for reference as we go through the next few exercises. All right. So the next thing we're going to go ahead and do is we're going to go ahead and, you know what? Let's look at the exercise. Exercise 3. So, of course, we still have some magic numbers in there, the magic number being 4. So that's fine for square, but we're of course we're math people. We've taken a geometry class. So maybe we want to go ahead and get a polygon. So make a copy of square, change the name to polygon, and that means we're going to have to add another parameter named n, because typically when you talk about, you could also say a polygon or an n-gon. Modify the body so it draws an n-sided regular polygon. So regular meaning all sides are of equal length. Recall that the exterior angles of an n-sided polygon are 360 degrees divided by n. Actually, should that be the interior angles? I'm pretty sure that's interior angles. Yeah, because if you have 4, it would be 90. So this should be recall that the interior angles of an n-sided polygon are of measure 360 degrees, 360 divided n. Again, a square 90-degree angle, so again, interior. So little typo there. So go ahead and give that a try. Let me give you maybe 90 seconds, 2 minutes, just to kind of think about it. You're going to have to further generalize the function. This time to do a square, or a polygon, n-gon. All right, let's go over it together. Go back over here. All right, so what I'm going to go ahead and do first is, I mean, you could copy and paste it. I'm going to just write it from scratch. So let's define polygon. It's going to have turtle, T. It is going to have length. No, I'm going to match with the way I did it. I actually did an end. I did the end first. So, and I'm going to have it default to square. Just as I like squares, but I am also going to put a default length of, let's say, 90 in again. So again, I set some default values. By the way, I don't think I said that. I may have said it, but just to make it a little bit more formal, n and length are called keyword arguments. Keyword arguments. So that's not how you spell arguments. So, oh yeah, it is arguments. All right. So if you ever say, "Hey, it's a keyword argument," and because it's the reason it is a keyword is because you say like n equal to something or length equal to something. You kind of saw these already with the print. You'll see them in the exercises where it's like print, and then it has like sep equal to quotes. It's just changing the separator. That's a keyword argument. Okay. By the way, whenever you have a function that's starting to be a little bit more involved, you probably should go ahead and put some triple quotes here. Does anyone remember what these triple quotes are right at the top of a function are called? It's called as docstring. So this function is going to, it draws a polygon with n sides. By default, it draws a square with length 90. T is going to be a turtle object. N is going to be the number of line segments. Length is going to be length in pixels of each side. So whenever you have a docstring, especially as these functions have more things going on with it, it's nice to say, hey, these are the parameters that it takes, and that's in the docstring. You could also even say like it returns none, because remember a function, if there's nothing specified, there's no return statement, it by default returns none. There's some other things that you can do starting in Python 3.8. I haven't talked to you about it yet. It's called type hinting, which kind of is better than docstrings, or not better, but it's an alternative. But I don't want to muddy the waters here today too much. So again, just wanted to have the docstring. So the angle is going to be computed to be 360 degrees divided by n. I'm going to do that little computation ahead of time. Then for I in range of not 4 this time, but n, what we're going to need to do is have our turtle is going to move forward some length, and then it's going to turn left again, but it's not going to turn left 90 degrees. It's going to turn left some computed angle amount. So you can see right here, if I do a polygon, let's call it pass in Bob with no other arguments for its default one. But just to go ahead and polygon, let's pass in Bob. Let's go ahead and say, I don't know, let's do a hexagon of length 100. And just to illustrate something, polygon T, and then you can also say n is equal to 10 and length is equal to, let's say, 40. And now let's run this. T is not defined. Oh, because, what did I do wrong? T is not our turtle, it's Bob. Bob. What is that from? We are Bob, I don't know. Feels like it's like some sci-fi. All right, good catch, Anna. So there is the default arguments. You can see right here is the hexagon, and you can see right there is the tengon. Couple things to note. Question first.
My docstring is causing it to not work. Bad input.
I just for the time being, then I'll have to look at it more later. Or just one thing. Hey, by the way, one other thing you can do when it comes to comments. you can always just wrap, hold on, let me see if I remember how to do this. I haven't used it in a while, and my languages are mixing in my head. You can use a docstring as a way to comment out a block of code, I think. Let me see. Yeah, no, it's because it's clashing with the other one. So let me check something. Yeah, if you need to comment out like a big block of code, you can just basically wrap it like that. And like see how I just use single quotes here. So little tricks that you learn along the way. I'll have to look into why that's happening. It's just a little probably syntax thing. So by the way, notice here when you if you don't specify what the keyword argument is, it's fine as long as you keep it in the same order as what's above. So different ways to call it. So any questions on the polygon function? All right. So one thing that I'd also say, notice how we have this 360 in here. This is a constant. So what I recommend whenever you find you're using a constant, so like in the first project, what were some constants that you all used? 100, maybe for a place value change, quarter value, penny value. A good standard convention is if you ever have constants just at the top, what you can go ahead and do is just put like degrees in a circle, and by convention, it's not like required by any means, but if someone else who is familiar with the Python language were reading your code, constants are typically all capital letters. And this is also kind of grandfathered in from C and other kind of more traditional language. So if you ever need a constant, typically define it at the top in capital letters. Anyway, fun little fact. So that means that this would be degrees in circle. And now all of a sudden you have a little bit better idea of what that is going to be. So it just helps self-document code a little bit. All right, so in that case, any other questions there? Yeah, Anna.
I made like a circle, but I don't really know how.
You made a circle, but you really don't know how. Okay, let me take a look. Let me put up the next exercise. So if you're good, you're able to do that. And Kenneth, I'll get a look at yours as well. All right, so exercise 4 here. And Anna, I guess you're a little bit ahead of the game, but I'm not sure why. Write a function called circle that takes a turtle t, radius r, as parameters and draws an approximate circle by calling polygon with an appropriate length and number of sides. If you think about this from a calculus perspective, think about how are circles constructed, and from a limits perspective, you just let the size become arbitrarily small and the number of sides become arbitrarily large. So again, this is kind of, you're considering this as like a limit problem, but your circle function should call the polygon function inside of it. Let me take a look at it. Okay, so that's kind of what this is getting to. So if you hit 1, just so I can see. So you're basically starting exercise 4 with not quite there. So you don't want to, it's because you, so let me think here. So 6. So if you do, because you have noticed that this is backwards. So.
Right, and my sides are 100.
It did 100 sides of length 6.
Cool.
So, and that's kind of getting into an issue we're going to talk about, because it basically didn't have enough rope to finish the shape. So. But yeah, you're starting to get to this idea by letting a really small
on purpose.
Of course.
Yeah.
And Kenneth, did you want me to look at the doctrine? Maybe fine for now.
We can look at it.
Okay. This one's a little tough. You might need to import pi. because you're probably getting hungry at this point. And it's related to a circle. So if you think about it, you're going to need to figure out how much circle that you're going to need to draw, which is the circumference.
Yeah.
You're going to probably need the circumference in here somewhere, so you know
So
how much.
the import math.
From math, import pi. Or you could import math and then just do math.pi, either way. But I think since you just need that specific constant, I think it would be better to go ahead and just from math, import pi.
Would we make our own arbitrary, like large and small constants, or how do you? 'Cause we can't take
That's kind of the issue that's going to show up. Like, how do you pick n? Let's start talking about it. So here's the reason. Here's the thought. So now that you've had maybe a moment to think about it, I don't want to dwell here too long, just in case someone's completely stuck and start thinking about dinner instead of programming, which I'm always thinking about dinner, but that's beside the point. So let's go. Here's how I'd approach this. So I'm going to define a function called circle. It's going to take a turtle and a radius, which I'll just call r, and I'm going to need to figure out how much he's going to need to draw. I'm going to need to basically I'm going to need to make sure I have enough to draw the whole circle. So I will need the circumference. So I'm going to go back up to the top and I'm going to say from math import pi, not piece, but pi. Wish it was that easy to import piece. Just import piece. World problem solved. Anyway, so we've defined circle with a turtle and a radius. The circumference of this circle, circumference, is going to be 2 times pi times r. And what we're going to do is I'm going to use a large n. So I'm going to just do something like 50. And Anna, this is kind of what you were running into when you reversed the arguments. You had a large 50, or a large n. And what we're going to need to then do is consider the length per side. Because again, we're just approximating it. We're going to have to take the circumference and we're going to have to divide that over n sides. So that will tell us how much each side's length is. So now that we have that set up, I'm going to go ahead and call the polygon function. In the polygon function, I'm going to pass in the turtle that was passed in the circle. And then I'm also going to pass in the length per side because that was the length of our polygon. Actually, I have to reverse that. So I'm going to need to pass in n first. So I'm going to need to pass in n, and then I'm going to have to pass in length per side. So you can see right here. So let's go ahead and see how this plays out. Let's go ahead and call this time a circle with Bob. And let's do it with, let's just do a couple different ones to see how it plays. So let's do circle Bob with 10. Let's do 100. And then circle Bob, let's do 1,000. I think that'll really illustrate what's going on. No, that may be too excessive because it'll take too long. Let's just do 500. Let's run this. All right, that looks like a circle. That definitely looks like a circle right there. But this last one, you can kind of tell Bob isn't quite doing what we ordered. He's really just drawing a bunch of lines, isn't he? You can see that is really large. And the other thing you can see, did he finish it? He did not. So, any ideas why he did not finish it?
Lazy.
He's lazy. Not quite as in. is probably coming from these floating points. You're basically rounding off enough times that is not. So you see, there's a little bug right here that basically, yes, it's chopping off too much of the float and it's rounding it down, so it's not getting enough. So how do we deal with that? Well, the thing to do is this n is kind of the issue. As n gets larger, we do have to be a little bit more careful about the circumference and the length right here. So what I'm going to do is, like I said, I don't really like just random numbers that don't have any relationship, like 50. Like, why do we choose 50? It seems very arbitrary. So what we're really going to do is let's adjust this. Instead of n being 50, let's go ahead and make it a function of the circumference. So what we're going to do is we're going to do some circumference divided by 3. And then what we're going to do is add 3 to that. The reason we're doing this, by the way, adding 3 guarantees the polygon has at least 3 sides. So that's a nice precondition. Again, a little bit arbitrary right here in terms of my selection of 3, but at least now our n is a function of the circumference. So if we need to draw a larger circle, our n will go ahead and reflect that. So let's go ahead and now run this and see how it plays out. Okay, start must be an integer on line 46. So anyone want to think about what went wrong here?
You got rid of n. Oh.
N's still being passed in, but be careful. When you're using n right here, it's now a function of circumference. So it's division, but remember the range needs an int, so we do need to cast this to an int to make sure that we don't have any issues with floats being passed to the range function. So we'll go ahead and run this right here. And you can see that this is much more circular. And let's see if the 500 one is resolved. It may take him a moment to get back. So cool about that. Yeah, question while we wait.
Parse error on line when I define circumference.
Line 50. Math. Did you do from math and 4 pi?
I just did it. You worked on that.
Parse error. Let me go back to line 50 and glance. 2 times. Oh, indent. Remember your function needs to be indented. All right, so I think our turtle got stuck up there. Is it coming down yet? Hold on, let me make sure that logic in my code is correct. Let's see, did I miss anything?
Almost halfway through.
So it seems like we don't have enough length per side from the looks of it. So where is the rest of our length? Oh, circumference divided by n. It stops halfway through. All right, let's debug this for a minute. Let's try just the 100 so I can see. So where is our logical miss right here? Int circumference divided by 3. Did I want to divide it by 3? Let's do this. Any ideas? I'm at a loss too. Something in my mind is not clicking. So, by the way, if you ever, let me use this as an opportunity. I do want to transition, show you one thing before we head out to the day. If you find a bug in your code, there's going to be a temptation to stare at it for 2-3 hours until you get it. Let me make a recommendation. Take a walk. Well, I say this from personal experience last Saturday where I stared at something for probably an hour. I'm working on some basically parallelism with matrix multiplication for my class I'm taking. Stared at it for an hour, came back to it, fixed within the first 2 minutes of me sitting back down. So don't wait to the last minute to do things, especially when it comes to programming, because bugs are going to happen. You're going to forget a indent, and honestly, the moment you step away and come back to it, you may be able to see it immediately. So let me pause the recording, because what I want to go ahead and do off the recording is just kind of preview what the next project's going to be. And then I'm going to get the directions out by tomorrow. I'm going to think about this, encourage you to think about what's happening here, and we'll revisit the beginning of next class. So first things first, stop recording.